also be very interesting.
Yeah, this is brand new. Thank you for inviting me, and welcome to this talk on VSCode-PRECISA. So I'm Paolo Masci, a senior researcher from the National Institute of Aerospace and NASA Langley, and I'll be giving the talk today. This is joint work with Laura Titolo, Maria Moscato, Marco Felio, and Aaron Daddle. The main body of the talk will be a live demo of the tool. I have just a few slides to kickstart the presentation. So as you all know well, it is important to create floating point analysis tools that can be used effectively by developers so they can quickly check if and how round-off errors propagate in a program. This is especially important in domains like avionics or automotive, healthcare, because even small errors can lead to catastrophic consequences. In this talk, I will use some examples from the avionics domain to ground the discussion on specific cases and demonstrate the capabilities of the tool. Before diving to the live demo, I would like to spend some words on PRECISA. So many of you probably know already PRECISA. It's a static program analyzer that is able to compute a sound and accurate over approximation of the round-off error in a program. And the tool also creates a certificate that can be used to verify the correctness of the result. PRECISA, similarly to other floating point analysis tools, provides a simple command line interface for the user interaction. And while this kind of interface is generally okay for research purposes, it can create really roadblocks for developers and also in education, because there is additional effort that is needed to set up the experiments, to choose the right analysis options, and to inspect the analysis results. I have here a couple of more slides on PRECISA, but I'll just skip them. They are here just for reference, and we can go back to these in the case it's needed at the end of the talk. So VSCode-PRECISA integrates PRECISA in Visual Studio Code. The toolkit provides a graphical interface with different views that can be used by the developer to perform the analysis from different perspectives. You will see that besides the basic round-off error analysis, you will be able to perform analysis like the sensitivity analysis, interval analysis, a comparative analysis between different implementations of a function, and a conditional instability analysis for if then else. So the best way to present these functionalities is to jump to the tool. So I assume you are able to see the tool at this point. Let me know in the case. So here you can see a function, NLComp, which is used in the CPR algorithm used in aviation to encode and decode the position of an aircraft. So in CPR, the globe is divided into sectors, and this function can be used to compute the lower limit latitude of a sector. So of course, it is important to check that this function behaves correctly, because otherwise an aircraft that is in sector XY might be misplaced in another sector. To start the analysis of this function in VSCode-PRECISA, we just click this inline command here over the function definition, and a new panel opens on the side. The default view is the standard round-off error analysis. And you can see here at the top, there is an input form that you can use to specify the range of input variables. The specific values are taken directly from the source code using an annotation FP range. If this annotation is not provided, the tool introduces some predefined ranges. To launch the analysis in PRECISA, we just push the Analyze button, and in a few instances, we get the results. So the numeric result is displayed in graphic form using a bar chart, and the height of the bar is the round-off error computed by PRECISA. The information is also displayed in a table at the bottom, where you can see the range of input values, the options used for the analysis, and the error. So as I said, this input form can be edited, so we can redo the analysis for different range of values. And as you can see, the interface collects the results and puts them in the interface. And this is useful because it allows to do a quick comparison between different experiments. So this is the basic view. The second view is the interval analysis. As explained here in the caption, this analysis splits the input range into a number of sub-intervals and performs the analysis on all of the intervals. So this is useful, for instance, if we want to understand what is the distribution of the round-off error for different values of input variables. For instance, in this case, it's interesting to see how there is an inverse linear relationship between the round-off error and the value of the first input variable. The third view is the sensitivity analysis. In this analysis, we do something slightly different. We assume that the data might be affected by some noise. So the actual value, the actual range might differ from the nominal range of the data. And what we want to do here is to see how this noise may affect the overall round-off error. For instance, here, I will be running the analysis assuming that there is a 1% uncertainty on the range of the input values. If we run the analysis, we can see that it's interesting to see that for some variations of the interval, the round-off error is actually larger than the nominal, the error in the nominal case, which is this one. So this information can be used by developers to create mechanisms that handle the situation correctly. Another view is the comparison analysis. So in this case, what we want to do is to compare the round-off error of two different implementations. For instance, let's consider this variant of the NLComp function. In this version, we are using a sine function, and we are avoiding the use of the square root for the computation of the lower latitude value. If we click on this button here, compare error bounds, the function gets loaded in VSCode-PRECISA, and we can simply push a button to run the analysis. And we can see easily here that this second version of the function is actually better than the first one because the error bound is much lower. The final example that I would like to show is with paving. So this is an example based on geofencing applications. So in autonomous vehicles, you could use this function here to check that the vehicle is within a certain regional space defined by this equation here. And here what we want to check is that the round-off error does not flip the decision whether the vehicle is in or out the region. In this case, what we can do is a paving plot where we visually see in the space what are the x and y's that create unstable conditions that may flip the outcome of the program. And in this case, this is the unstable region. Here, the analysis is coarse grain, and we can improve the accuracy of the analysis by improving the depth. So if we reanalyze, we can see that, as expected, this is, so the region of instability is around the border of the area defined by this function, which is an ellipse. To conclude, as you have seen, this front end provides different views that can be used to run the analysis using a push button style. And this can be very helpful when somebody wants to do a quick analysis and for people that are new to the analysis of floating point. The tool is currently connected to PRECISA, but I think this kind of front end is pretty general. So we should be able to connect this to other floating point analysis tools. And I think we will be exploring this possibility in the coming months. And I think that's all from my side. So if there are any questions, I'll be happy to answer them.
Yeah, very, very cool. I've always wanted to build something like this, you know, for my own sort of tools and runtimes for EpiCore. It's very cool to see it, like, you know, VS Code is the future. Everybody's using this environment. It's better than Emacs or something like that. But so just for me, how much work went into writing the actual front end? But like, what was involved with that?
So if you're familiar with VS Code and with the APIs, you can go very deep very quickly. So I was already familiar with VS Code because I've been using it for 2 or 3 years. So it took a month, I would say. So most of the time was actually spent not in the implementation, but in the design of the interface. So we had to understand what are the views that make sense. And we had some iterations with people in the group using PRECISA to understand if the views made sense and do little adjustments to improve them. So yeah, that's how it happens.
Yeah. Cool. I mean, cool interface. You extra bonus points for like a movable 3D visualization. That's always very, very cool to see. But yeah, so is it using like the VS Code server to run the tool?
Yes.
As part of the, okay. Yeah, it's like the standard plugin thing or whatever, but yeah, cool. I think Ganesh had some questions there. I've seen them zooming by in the chat along with some other
I just put it up saying, in general, do folks at NASA use automatic differentiation tools on their codes, and does it provide any additional benefits, scalability, or other things? Yeah.
Sorry, was that a question?
Yeah, there are communities which use automatic differentiation tools, such as CodiPack or Enzyme or things like that. So I was wondering whether you have started using automatic differentiation tools in addition to PRECISA. Yeah.
Not for the moment, but I think it's in our plans for the next months.
Okay, thanks.
Cool. All right, more discussion on Slack, always welcome. I think there was also some in the chat there, which is good. Hopefully